Hey y'all, today we're going to be talking about the heat of fusion and the heat of vaporization. So I talked little bit about it back in heating curves. So the heat of fusion is responsible for the melting or the freezing of a substance, and then the heat of vaporization is responsible for the phase change between a liquid and a gas, or a gas and a liquid, so condensation or evaporation. In this video, what we're really going to talk about is the math behind it. Okay, so the heat of fusion is the amount of heat energy needed for a substance to change from a solid to a liquid, or vice versa. And the way that we calculate that out is we take the mass and then we just multiply it by the heat of fusion. So we don't actually have to figure out what this delta heat of fusion is. Generally, we're just going to use it to calculate how much heat is being generated. However, you might end up seeing problems where you have to find the delta heat of fusion. So you're given heat and mass, and we find that, and we find our heat of fusion. But this isn't too bad. So let's kind of get into it. So our first problem here says the heat of fusion of water is 334 joules per gram. How much energy is required to melt 50 grams of ice into liquid water? So again, our equation is Q is equal to our mass times our heat of fusion. So we're looking for Q. We're given mass. So mass is 50 grams here. So we put down 50 grams. And then our heat of fusion is 334 joules per gram. So 334 joules per gram. And then we just type that into our calculator. So 50 times 334 will give us 16,700 joules. So it will take 16,700 joules of heat to completely melt 50 grams of ice into liquid water. Okay, so let's do another one. So if it takes 41,000 joules of heat to melt 200 grams of solid copper to liquid copper, what is the heat of fusion of copper? So here we're actually looking for the heat of fusion. So again, our equation is Q is equal to mass times the delta heat of fusion. And in this case, we're actually looking for this delta heat. We are given our Q, we're given this 4,100 joules of heat. So 4,100 joules. And then our mass of copper is 200 grams. So 200 grams of copper. And we're looking for our delta H. I'm just going to put delta H. I'm going to put F for fusion there. Okay. So because we're multiplying here, we have to divide both sides by 200 to get this delta H by itself. So divide by 200 grams. We're going to divide this by 200 grams. And so then when we type that into our calculator, we type in 4,100 or 41,000, excuse me, divided by 200, and we'll get 205. So our delta H of fusion for copper is equal to 205 or 205 joules per gram. Okay, so two different things that we were looking for in our first problem. We were looking for the amount of joules needed to melt ice into liquid water. And in this case, we're actually looking for the delta heat of fusion of copper. So the next thing is the heat of vaporization. So your heat of vaporization is the amount of heat energy needed for a substance to change from a liquid to a gas or vice versa. Okay, so you add heat energy to change from a liquid to a gas, you take away heat energy to change from a gas to a liquid. And so let's look at how to work with some math. It looks the exact same. It's still Q equals to M times delta H. It's just this time our H is vaporization. So this question is asking us, or tells us, the heat of vaporization of water is 22,257 joules per gram. Okay, so much more heat energy is needed to change liquid water into gas than solid water into liquid, right? So the heat of fusion was 334 joules per gram. The heat of vaporization of water is 2,257 joules per gram. So this time we're going to figure out what energy in joules is required to convert 50 grams of water into steam. So like I said, the last one we did with water, or the first one of the heat of fusion that we did, we looked at 50 grams of water or ice turning into liquid water. And now we're going to change 50 grams of liquid water into steam. So let's see how much energy that takes. So Q is equal to mass times delta heat of vaporization. I'm just going to use a little V there. We're looking for Q. We're given our mass as 50 grams. And then our delta H of vaporization is 2,257 joules per gram. So let's type that into our calculator, see what we get. And we get 112,850 joules. So a whole bunch more energy is needed to change liquid into gas. Okay, so, and this is joules. So energy is always in joules. So now our next question tells us that liquid sulfur vaporizes at 445 degrees Celsius. If it takes 28,125 joules to convert 20 grams of gaseous sulfur, what is the heat of vaporization of sulfur? So again, we're using this Q is equal to M times delta H of vaporization. A little V there. It gives us Q, and that is 28,125 joules. It gives us our mass, which is 20 grams. And then we're looking for this delta H of vaporization. So our heat of vaporization here. So we're multiplying, so we have to do the opposite to get this delta H by itself. So we're going to divide both sides by 20 grams to then get our answer. So delta H of V will be equal to 1,406, and I'm just going to round it, joules per gram. So your calculator will tell you 1406.25. I'm just rounding it to 1,406. Okay, so that's how we find our delta H of vaporization using our mass and our heat energy.